All right, welcome to PreCalc. We are going to do a test review today, and I'll see if I can't put these on writing as well. So I'm just going to go ahead and share my screen, and we can get started. All right. So what am I going to ask you for your quiz 2? All right. Well, just give you an overview. Okay. We are going to ask you to graph an exponential or logarithmic function. Okay. Okay, that's one thing we're going to do. Second thing we're going to do is we're going to have a properties of logarithms. Okay, it might be a domain question, so we'll do a domain issue in a minute as well. We are going to solve an exponential equation. And we are going to solve a logarithmic. Equation. All right, I'm going to forgive me on this one. The one I picked for your quiz actually works out to be rather nice, but these equations are actually hard to come up with a nice one like on the fly, and I don't have one handy. So the one I'm going to show you is going to be a disaster. It's going to be awful, but the one you're going to have to do for the quiz is not nearly as involved. So I just want you to know that, so that you don't think like you're not really going to ask us all of this stuff, are you? Like, no, it's going to work out nicer. So all of the steps that we have are going to be present. It's just that the steps that we're going to do together here are a little bit more involved than the ones you're going to be doing on your quiz. Okay. So graphing an exponential or logarithmic function. Okay, so what if I have you graph something like y is equal to 3/5 to the x power? Okay. Now, all I want to see you do is make a t-table. Okay, so pick your x's, pick your y's. So usually, I mean, any x's you pick are going to be fine. I would suggest like a standard -2, -1, 0, 1, 2. Okay, that's a pretty standard set of points that people pick. You always want to pick some positive ones and some negative ones. 0 is always a good choice. So 3/5 raised to the 0, right? That's just 1. 3/5 raised to the 1, that's just 3/5. Okay, about 0.6, right? And squared is going to be 3/5 squared, and that's going to be 9/25. Okay, we can figure that out in a minute. To the -1, 3/5 to the -1, that just means take the reciprocal, right? That's just 5/3. Okay, a little bit less than 2. And then 3/5 to the -2. We take the reciprocal, so that's 5/3, and then we square it, and that is 25/9. Okay, again, about 2 something, like not quite a half, but go ahead and make a decimal for it for the sake of argument here. So 9 divided by 25 equals 0.36. Okay, and then we go on the other side of it. So 0.2778. Okay, so here's 0.36 and 2.778. Okay. Graph x, y, 2, 1, 2, so -1, -2, 1, and 2, and then here we go, right? So when x is 0, y is right, y is 1. When x is 1, we're at about 0.6-ish. When x is 2, we're about 0.36, right? X is -1, right? 5/3, close to 2/3, close to 6/3, so we're up here. And then -2, we're up here at almost 3. And connect the dots, pretend these all connect, and then you're set. Okay. So let's take a look at logarithms. Okay. About log is equal to, or y is equal to log of, trying to come up with one that I didn't ask yet, 3/4 x. Now, the key with these is you have to turn into equivalent exponential form, right? So it's, how do you read this? It's log base 3/4 of x, right? So 3/4 is your base. All right. Now, when I was a little kid, they showed me a logarithm once. I didn't understand what it was. I asked, I was like, what's a log? It said, it's an exponent. Thanks. That was really helpful to somebody who doesn't understand exponents. So, but that answer stuck with me because the answer, like it made sense. Like years later when I learned logarithm, I was like, oh, the answer is an exponent. The answer is the exponent. So if you're studying logarithms and somebody doesn't really know what you're talking about, you could always tell them, oh, a logarithm is an exponent. You're not lying. The answer is the exponent. Okay. It's just not a useful answer. So this is equivalent to 3/4 to the y is equal to x. Okay. Now, the other thing to remember is that logarithms are inverse functions to exponentials. And you know how when we found out, when we calculated or constructed inverse functions, we swapped them? So we're going to do the same thing here. So instead of picking my x's, I'm going to pick my y's, but I'm going to make it look like I picked the x's carefully. So with the y, we're going to do -2, -1, 0, 1, 2. Okay, just like we did for x's before. Now we're doing it with the y's. All right. Now we're going to use this equation. 3/4 to the y is equal to the x. Okay, so we want 3/4 raised to -2 is equal to x here. So this is going to be 4/3 squared is equal to x, which is going to be what, 16/9. Okay, so this is going to be 16/9 here. Okay, 8/16 would be half, so 9/16 would be going to be a little bit. Okay, so here we have 3/4 -1. Okay, this is just going to be 4/3. Okay, 3/4 to the 0, right, to the y. At this equation right here, this is just going to be 1. 3/4 to the 1. Okay, that's just 0.75, 3/4. And then 3/4 squared, 3/4 squared, that's going to be what? That's going to be 9/16. 9/16. Okay, again, close to 8/16, so a little bit more than, 0.5-ish, a little bit bigger. 0.751, 4/3, 1.33, and 16/9 is going to be like, not quite 2, but maybe 1.9. Okay, you can always check. Okay, what's 16/9? 1.7. Okay, delightful. Okay, we'll call it 1.8. Okay, and this is what I'm going to graph. Now, here's the thing. Do I have any values of x that are negative? No. We have values of y that are negative? Sure. -1, -2. 2. And then what do we have to go on our x to? We have to go about to 2. So we'll go call that 1, call that 2. Okay. So when x is 1, y is 0. So there's your point. When x is 0.75, right, 3/4 of the way, y is 1. Okay. When x is 9/16, so it's like a little bit more than half, y is 2. Okay. When x is 4/3, so that's here, down here, -1. And when x is 16/9, which we said was 1.8, so about here, and we're good. So what we're looking for is something that looks like that. Okay. So notice no negative values of x's in my graph. Okay, and it's got like an upside down sort of a logarithmic curve here, right? So something like that. It's always 1, 0. So that's how you graph a logarithmic function, right? So practice these two. Don't practice like 3 to the x. Okay, I'm not going to ask you one that easy. Same thing. But don't practice log y equals log x. I'm not going to ask you one that's easy. Okay, it's going to be a weird base. There might be a plus in there, like log x plus 1 kind of a thing, but for the most part, this is what gives people the most problem. Practice with weird bases and practice how you draw this t-table, because this is what I'm looking for, and I'm also looking at your picture. Okay, So, and if you're going to use like a weird way, like if you decided, hey, I'm going to memorize change of base formula because I don't have enough stuff to memorize in my life, tell me that you're using the change of base formula, okay, to get your values. Don't. I would recommend not memorizing that because you're going to have enough stuff to memorize. But you know, if you're going to use something that's like a little bit different than this method, please let me know what you're doing so that I can see what's happening and how you're getting this. Do not, okay, you're not allowed to use a graphing calculator, so the calculator I'm showing you is a legal one. There is a way to get weird bases off the calculator like this. I don't want you to do that. I certainly don't want you to graph it on here, but I want you to go through and figure out, like, because this is my way of testing. Did you know equivalent exponential form? Okay, and do you know the graph? So this problem is doing double duty for me. Okay. All right, next one, properties of logarithms. And domain. Now, you can't take the logarithm of a negative number. Okay, so that's a thing to deal with. So if I'm going to be easy about it, I won't be. Right, we'll just do log of like x minus 3. Well, then your domain here, right, is just going to be x greater than 3. Right, it can't be 3, so it can't use an equal sign here. So domain would be 3 off to infinity. Okay, and remember, this is just a shift, right? This is a shift to the right 3 points. So if I wanted to graph it, I won't ask you because I just did the problem before. We would have our asymptote here. Here's 4. And we're going to have our logarithm. Okay, but the domain is what I'm going to ask. Not going to be that easy. What if I ask you to graph something like y is equal to log of, let's go with x plus 3, okay, x minus 1, and x minus 5. Uh-oh. You remember your 2.2, how to graph polynomials, right? Like it was yesterday, of course you do. So how do I graph? So really what we're going to work on, x plus 3, x minus 1, x minus 5. Okay. So how do we graph that? Well, go to 1, 2, 3. There's negative 3. There's positive 1. There's 1, 2, 3, 4, 5. There we go. What kind of a graph is this? It's a cubic polynomial. So I know the end behavior looks something like that. So when I get down to negative 3 here, we're going to have our end behavior. It's going to pop up over the axis, hit there. Okay, pop under the axis, and then go off to infinity that way. So here's, when we want to figure out the domain, where is this thing positive? Right, where is this positive? Well, it's positive here, and it's positive here. That's my domain. So how do we write that down? Okay. So the domain of this logarithm, right, is going to be, we have negative 3 to 1. Notice if I include 1, we get a 0. We can't take a logarithm of 0. Okay, union. Now we got to find the next place where it's positive. 5 off to infinity, right? That's your domain. Okay, we just want the positive parts. Draw a picture, get the positive parts, you're set. If there's a weird parabola in there, right, graph the parabola, pick the parts that are positive, and then you're done. What if I asked you, okay, so let's give it a slightly harder problem here. So what if I said we had something like square roots of x times x squared plus 1 divided by the cube root of y. Okay, that looks scary and terrible. Okay, so what we're going to do is we're going to change some of these radicals to rational exponents first. Okay, so this is the log. And then here we have x times, we have x squared plus 1, cube root of y. So that's to the 1/2 power, right? That's what square root means. It's to the 1/2 power. So how are we going to do this? Right? We're going to say this is 1/2 log of x times x squared plus 1 over cube root. Actually, let me change my cube root to a 1/3. Let's get rid of that. All right. So these two are timesed, right? These two are timesed. So this is going to be 1/2 log x plus 1/2 log x squared plus 1. Okay, minus because it's in the denominator, right? It's minus. And then we have a 1/2 because the square root is over everything. 1/2 times 1/3 because this 1/3 can come down in front log of y, right? So 1/2 log x plus 1/2 log x squared plus 1 minus 1/6 log y. That's what they want you to do. Okay. What I'm trying to do with this particular problem is I'm trying to bait you into making a mistake. I'm trying to make you think, well, maybe I should simplify this too. You don't have a rule for log of a plus b. You can't break this apart. If you have log of a plus b, you're screwed. You're done. It's over. Okay? There's no breaking this apart. Okay? So don't think like, hey, I could do more. No, they can't. Okay? You'll be very unhappy if you do. You have to remember, okay, and yes, you have to memorize. Okay, not just like for a test, but for the rest of your life. Okay, log of AB is equal to log of A plus log B. Log of A over B is equal to log A minus log B. And log of A to the R is equal to R times log A. All right. And a teacher that would say, you have two kinds of formulas. You have formulas you memorize for the test. There will be some of those, not on this one, but on others. And then there's rules, there's formulas you memorize for the rest of your life. This one you're taking to your grave. All right, like I don't care. Alzheimer's can take away like the birthdays of your siblings before it should take away this. Right. So this you remember until they put you down. All right. That's the kind of thing I'm gonna ask you. There's another form of this where they give you this thing, and they say turn it into one big pile. The number of times I've had to do that, I can kind of count on one hand. I've not had to take all of this and turn it back into this point, but I have had to take this thing apart and turn it into the little pieces more times than I can count. So going in that direction, going back up the ladder, like I don't think is a great and useful skill, but taking this big pile of polynomials here and breaking them down into individual logs, that is a very important skill. Okay. When you get to calculus, if you've had calculus at this point, and somebody says take the derivative of this, I don't know if I'd want to do that. Okay. This would not be a fun problem. If you've taken calculus and you know what that means, right? You've got a chain rule with a nested product rule with a nested quotient rule. This is not a fun problem in calculus. However, if you convert it here first, right? And it says take the derivative of this, not a hard problem. So that's a section you're going to get to when you learn calculus of something called logarithmic differentiation. So this skill is not going away. You're going to have to do it again. Okay. So that's why I think this is the more important skill than taking this one and then pushing it back up. So it's very likely you'll see a problem like this, okay, with nested square roots or nested cube roots. Okay. Sorry, it's my cat's destroying the house. And then graphing, or finding the domain, typical math problem. You guys worked a ton of this and how it works. So there we have it. Okay, solving a logarithmic equation. Okay, let me just say this as well. As we're going through the test review, this is longer than your actual exam. I only picked 4 problems. They're not the easiest problems, but they're certainly not the hardest problems. Okay, so when we get to number 4, you'll see what I mean. It's not a problem that's that hard. There's 2 flavors. Okay, there's something like a 3 to the 2x minus 1 is equal to, how about a 20 of like 4 minus 3x kind of a thing. Okay, how do we do this? Okay, this is a standard, like if you took college algebra, they should have asked you a question like this, right? So what we're going to do is we're going to take the log of both sides. So this is log 2x plus 2x minus 1 is equal to log of 20, 4 minus 3x. Remember the rule we just went over? This guy here, log of a to the r is equal to r times log a. We're going to pull this stuff down. So this is 2x minus 1 log 3 is equal to 4 minus 3x log 20. Now, if you can't deal with the logarithms because they're scary, and I understand, okay? I want to repeat. I just want to show it to you in a different form. Okay. The reason I either use base 8 or base 10. I won't. If it's your choice on which log you want to use, why would you use something that isn't in your calculator? So you might want to say log 3. Okay. And that is 0.4772. Always 4 decimals. Okay. We used to have something called CRC books, and we would have to look up logarithms in the CRC book. They always came in 4 decimals. So my rule is 4 decimals, 0.4772, 0.4771. Okay, is equal to 4 minus 3x. Okay, this is log of, right? This is log 20, log 20 equals 1.301. 1.301. If you want to solve this problem instead, okay, I will document point for it. Okay, but if you can't, if this doing it this way confuses you or is frightening or whatever, you're not going to get the 6 out of 6. Okay, but here's the deal: do it this way, you'll get a 5 out of 6. Right, and that's a B. Okay, 5 out of 6 is like 0.83 or something. That's a B. So if you have to convert it to do this, settle for the B and realize like, I'm not going to get full credit for this one, but a B is better than nothing. Get the damn B. Okay, don't look at it. I can't do anything. I don't know how to do it. No. Take the log of 20. Write that down. This is an algebra 1 problem. Okay, I have faith you could at least do this. So get your B. Now, what about the rest of it? Well, this is 2x log 3 minus log 3 equals 4 log 20 minus 3x log 20. All right, it's kind of like pi. It's just there's your number. I'm sure it's delightful. But 2x log 3 plus 3x log 20. Right? This moves over. This log 3 moves over to the other side. So we have a 4 log 20 plus log 3. You don't have to go back to do the previous stuff we did by combining everything. That's not required, right? So what's common? What's common here is an x. So we have an x. Here we go. 2 log 3 plus 3 log 20 is equal to 4 log 20 plus log 3. Okay. Last thing you're going to do is you're going to divide by this number. Okay. I know it doesn't look pretty, but it's still just a number. So 4 log 20 plus log 3 all over 2 log 3 plus 3 log 20, and you're done. Don't touch it. Okay, just leave it alone. Oh, I don't want a calculator approximation. That'll cost you the B, right? That'll cost you your A. So right there, that's an A answer. Convert it to a decimal, that's a B answer. The reason why is you don't know. You don't know how many decimal points the person asking you this question is going to need. Okay, if you call up a cement company and you say, hey, I would like 1.301 tons of cement, they're going to laugh at you. Okay, they don't deliver tons of cement like this. Like at this point, you're doing, I need 1.5, okay, or 2. I mean, because that's how they deliver cement. It's like it's not, they don't deliver, they might get half, but like there's like 1 or 2. There's no, less. So don't call up a lumber company and say, I need your lumber cut to 0.4771 inches. Like they're not going to do that. Okay. So that's why it's like If you're going to be making a circuit and you need 0.4771 centimeters of wire to go from one place to another, then that's fine. That might be your tolerance. But if you call up somebody like a cement company and say, I need 0.4771 tons, like you want a half a ton. You don't want that. So I don't know what the tolerance is. You leave it like this. You let the person who's doing the project figure out what the tolerance is, and they'll calculate this. Okay. You solve the problem. Leave it to a context before you give me a number. Okay. All right, that's one flavor. What's the other flavor? Let's see here. Come up with a nice problem here. Pretend you didn't see this. This is 2x minus 1, and we'll do a 3x plus 2. Okay. So what does we have here? We have 6x squared. It's 3x plus 4x, right? Okay, minus 2, so this is 6x squared plus x minus 2. Okay, so what we're going to do is we're going to have a, that's all right. We're going to have a 6e to the 2x plus e to the x minus 2 is equal to 0. Okay, now we're going to forget this ever existed. Okay, and I'm going to say solve it. You're not going to have this. So how do you solve? Well, we're going to use something called the 8C method. Okay, because we have to factor this. So the first thing is we're going to let u is equal to e to the x. Okay, so we have 6u squared plus u minus 2 equals 0. Then what we're going to do for the AC method is you multiply the a and the c together. So 6 times negative 2 is negative 12. And then we have to come up with two numbers that multiply out to 12. So it's going to multiply to 12, but it's only going to add up to 1. Okay. So what are the factors of 12? We have 1 and 12. Well, that doesn't add up to 1. And 2 and 6, that doesn't add up to 1. And 4, and, hey, look at that, 4 and 3. Okay. So we're going to have 6u squared minus 3u plus 4u minus 2. Did it matter what order you put them in? No. I just like to group 3's with 3's and evens with evens. Okay? 2's with 2's. I just like to, I'm just using my best judgment as I'm going through trying to do it. Doesn't matter which way you go first. And it matters your signs, but you know as well as I, like if you owe somebody $3 and you pay $4 on your account, then you're $1 credit. If you pay somebody $4 and something only costs $3, you have $1 credit. Okay, so it doesn't matter if you give them the money first and then buy your stuff, or buy your stuff and then give them the money. Okay, so the minus and the plus doesn't matter which order it goes into, as long as you get it in the right direction. We wanted a positive 1, so 4 minus 3, that gives us positive 1. So now let's factor out the 3. So we have 3u, right? So we're grouping this. We have 3u, what is left? 2u minus 1. Okay, plus 2. Okay, because 4 and 2, we take out a common thing, that's a 2. And we have a 2u minus 1. That's common. So we sweep that forward. That's 2u minus 1, 3u plus 2. This is all equal to 0 still. Okay. So we solve and we say, okay, great, this is u is equal to 1/2. And this is u is equal to negative 2/3. Right? What the heck was u? Well, we look back up a couple of steps. U is equal to e to the x. Right? So we have e to the x is equal to 1/2. E to the x is equal to negative 2/3. Get me out of the way. Okay. Can I take the logarithm here? I sure can. So this is natural log e to the x is equal to the natural log of 1/2. X times e to the natural log of e. Natural log of e is always 1. Is equal to natural log 1/2. Okay. What about over here? We have natural log of e to the x is equal to natural log of negative 2/3. At which point you should say, wait a minute, something's wrong here. You try to type this in your calculator and it's going to work. But from the step above, right, what's the graph of e to the x looks like? You should know. It's like that. Are there any negative numbers on this graph? Does it cross any negative numbers? Does this graph cross down here at all? No. So this is a no solution. So the only solution we have is x equals ln 1/2 We're going to be a little sneaky about it because most textbooks are, is we're going to say, well, 1/2 is a fancy way to write 2 to the -1, isn't it? So this is negative ln 2. Okay, so x is equals negative ln 2. Say, wait, I thought you said there couldn't be negative numbers. Like, well, the y values are negative. Are there any x values that are negative here? Yeah, there's a whole bunch. Okay, so it's okay to have negatives in your x's, just not e to the x equals, because there's no negatives down here. Okay, so that's how you solve a problem like that. I am very fond of these problems. So the first problem I showed you was like the standard one, but you should not be surprised to see something like this happen. And I am very fond of making you use this method, the factor, because I know that in New Mexico, we teach this in ninth grade, and then they just say, oh, it's not important, never use it again. That's not true. It is important. You will use it again. So I asked. All right, last one. Okay, sorry for the length here. It's going a little long. Okay, logarithmic equations. Now, before we start, things about logarithmic equations. So with rational equations, right, that's like the fractions. There's places like if I do if I have an equation that involves this term, what if you get an answer that x equals 3? Is there a problem? Yeah, there's a problem. You can't do that. This is not a solution. Okay. What about radical solutions, right? In intermediate algebra, we learned all sorts of things like x minus 3 root is equal to like 2x minus 1 square root plus 7. We had to solve this. It was a great time for everybody. It's too much fun. Nobody should ever be allowed to have this much fun ever again. But there was a chance, right, that you would get something like x equals 2. Right? That's not the answer here, but there was a chance that you can get an extraneous solution. If I put 2 in here, what happens? We have square root of -1. We're not doing that in this section of the classes. Okay, they're complex numbers yet. So we get the trig, there'll be complex numbers. You'll have more fun than you should be allowed. But we get this, that's not a solution. Can't graph it, okay, on the xy plane. So there's a domain issue, there's a domain issue. Guess what we're going to do with logarithms? There's domain issues. You must check your answer. Okay, you don't have to check it for accuracy. You have to check it that you're making a positive number, right? You have to check that this is not division by 0. You have to check that you're taking the square root of 0 or something bigger. Okay, with logs, you have to make sure you're taking your answer that you're making sure that it's bigger than 0. Okay, so that's you will lose a point if you don't do this. So you tell me that you checked. Okay, otherwise it's automatic 1-point deduction. Okay, which is 1 grade deduction. Okay, so it could be perfect, but if you don't write down, I checked, I'm marking you off, right? Or give me some indication that you checked. You don't have to say those words exactly, but still give me some indication you checked the answer, okay, that it worked. Otherwise, whatever you have for it, that goes down to a automatic, all right? So let me give you one. This is not gonna, I promise, when I pick the one out for the exam, it works, it's very nice. This one, I'm not picking one that's going to be nice. Okay, I'm just going to pick one and we're going to hope for the best. Okay, and if I pick one that actually works, then I'm keeping it because these are not the easiest ones to come across. So we're going to do, how about log of 2x minus 1. Okay, and then I'll save you this part. We'll say this is log of x minus 3. Sorry, I don't want that parentheses there. There it goes. Oops, what happened? There we are. All right, and we'll say, oh, let's give you a weird base. Okay, let's do log base 7. We'll say this equals to 2. So the way you're going to have to solve this, okay, is first thing, put these together. Okay, see, I will ask you a little bit. So this is log base 7, And this is now going to be 2x minus 1, x minus 3 equals 2. Okay. So we have 2. We have to factor this out, or FOIL this out. This is log base 7. This is 2x squared, okay, minus x minus 6x, right? Minus x minus 6x plus 3 is equal to 2. Okay, this is 2x squared minus, right? You're $1 in debt, you spend $6 more. Congratulations, you're $7 in debt. Okay, this is log base 7 equals 2. All right, you've done some homework. How did you get variables out of an exponent position, right? What if you had like an e to the x minus 2 equals some stuff? How did you solve the x minus 2's here? You took a logarithm, right? You said natural log x minus 2 is equal to log of whatever this was, right? And then we pulled this down using the rule. Logarithms and exponents are inverse functions, so they undo each other, kind of like square roots and squares. How do you think we're going to get the variables outside of the logarithm? We're going to need some kind of an exponent. What's the base? The base is 7. So what we're going to do, and please write it this way. If you write it like it looks like a multiplication problem, I will mark you wrong. Okay, so you want to write it so that this is actually looking like a base, right? So we have a 7, we have a 7, right? So this is 7 raised to log base 7 of this, 7 squared. Okay, that's a rule. If you have e to the natural log of 3, you're going to get 3. If you have e to the natural log of pi, you're going to get pi. E to the natural log of 27 is equal to 27. I don't keep picking 3's. E to the natural log of 100 equals 100. Try it on your calculator if you don't believe me, right? But that's a rule. Okay, that's how that works. So 7 raised to the log base 7. This is just whatever was there. This is 2x squared minus 7x plus 3. 7 squared is equal to 50. All right? So that's what we have to work with. Subtract 50 from both sides, subtract 50 from both sides. Great, because it has to be 0. The 2x squared minus 7x minus, what do we have here, 47? Oh, I should have considered my numbers better. 47, I think 47 is prime. So 2 times 47 is going to be, what? It's going to be 7 and that is going to be 13. It's going to be 94. The only two factors for 94 is 2 and 47. That ain't adding up to 7. So what do we do when we have a quadratic? You can't factor it. See yourself. If only somebody came up with a formula that would let us solve quadratics. Oh, wait, there's a quadratic formula. So in order to solve the rest of this, okay, like I said, I promise yours is not going to involve this step. All right. So negative b plus or minus the square root b squared minus 4ac. See, I told you there's formulas you take to your grave. This is one of them. Okay. So this is x is equal to negative b, 7, plus or minus the square root of 47, right, b squared, minus 4, and then a is 2, and b is, or c rather, is negative 47. So there's no way I'm going to do that in my head. Divided by 2a, right? So this is 7 plus or minus the square root. Oops, not 47, thank you. It's 49. 7 squared is 49. What the hell did I do there? That's 49 minus 49 minus 49. So a lot of you are looking at this like, what the heck happened? 3 minus 49 is 46. Sorry about that. Okay, there we go. 46. Okay, since we're already in the thick of it, we're just going to keep going here. Okay. 49. B squared, 49. So we have 49 plus, because negative signs cancel, right? And then we have 4 times 2 times 46. 4 times 2 times 46. Okay, 368. Right? All over 4. So here we have 7 plus or minus the square root. What is 49 plus 68? 368. It's 49. It's 417. I don't think this has a nice square root. Okay. Although it is divisible by 3. So let's see. If we divide 4 by 3, what do we end up with? 139. That's not divisible by anything. That's not going to work. Divided by 7. Oh. 13. Nah. All right, that's pretty much, we're not fishing around for perfect squares out of that. It's not happening. Okay. So we're stuck with this. Okay, so my x is equal to 7 plus root 417 divided by 2. X equals 7 minus root 417 divided by 2. What is 4 minus root 417 divided by 2? Okay, so this is 7 minus the square root of 417. 417. There we go. Okay, divided by 2. That's 6.5-ish. All right. Go back to your original equation. This was the original equation. Okay. What happens if I type in negative 6.7, okay, into this equation? Well, negative 6 minus 3, right? You're $6 in debt. You spend another $3. Now you're $9 in debt. That's the logarithm of about negative 9. That doesn't exist. This answer doesn't exist. It's not real. Okay. This one, right? 7 plus. Well, that's going to be some kind of a positive number. Okay. It's going to be at least 7, right? Because it's 7 plus some stuff. 7 minus 3, positive. Okay. 7 minus 3 is positive. 2 times 7 minus 1, 14 minus 1, that's positive. So this one's okay. Okay. It's not always the positive answer. Okay. You have to check them both. Don't just cross this one out and say I checked, because I know that that's a lie. All right. So don't do that. Check them. Make sure. Okay. Checked. Okay. You can say checked by inspection. Okay. Because sometimes even writing that is slower than checking. Okay. So I just want you to just inspect your answer and tell me whether or not you checked it. Okay. You don't have to go through a formal process of checking. Okay. So that's all you have to do. Right. Again, your problem not nearly as involved with something like this. All right. But so it'll be factorable, but it will be something like this. This is my favorite flavor of logarithmic equations. All right. So that's what you have to deal with. All right. Hopefully that helps with your test review. If you have other questions, please let me know. I will try my best to put up another video for you if I'm asked, and hopefully clear up that situation. Okay. So thank you very much. I'm sorry for the length, and good luck on your quiz. All right.